we're going to talk about why the limit of the difference quotient is the appropriate formula for the derivative. Remember, the derivative is the slope of the tangent line at some point. For example, if f of x is equal to x squared, that means f of x looks like this. And whether you know it or not, f prime of x is 2x. Now this is the slope formula. If I want to know of the tangent line for at x, if x is 1, if I want to know the slope of that tangent line, since x is 1, the rule says, the slope rule says double x. So the slope here is 2. At negative 2, the slope of the tangent line where x is negative 2, well, the slope rule says double the x. But if x is negative 2, the slope of the tangent line where x is 2 on the x-axis is 4. If x is 3, go up to the graph right here, the slope of this tangent line, well, is going to be f prime of 3. And the f prime formula just says double x. That's the slope. Here, the slope is going to be f prime of negative 2. Over here, the slope is going to be f prime of 1. That is, f prime of 1 is 2. F prime of negative 2 is negative 4. The derivative gives you this, the derivative formula, f prime, tells you the slope of the tangent line, not for f prime, but for f. Okay, you go to the f function, and then the derivative is the slope formula. So now, like I said, we're going to try to motivate why it is what it is. So let us consider, say, that graph, f of x. And I want to know the slope of the tangent line right here. And of course, that is going to be the tangent line. But I don't really want that there now. It didn't come out nice anyways. So let's pick a point. So here's f of x. Let's pick a point delta x units away. Well, for example, if you're at 5 and you go 3 to the right, then the number here is going to be whatever 5 plus 3 is. So the number here is like I went 5 plus 3 to get the number over here. I'm going to do x plus delta x. So this point here, now let me put it further away. Sorry. So let's suppose that that distance is delta x. Let's even go further. Sorry. Over here. So this distance, that is, this distance is delta x. The point right over here is going to be x plus delta x. Okay. That point is right here. Now, let's say no to this answer. The slope of this line is not very close to the slope of the tangent line. But what is the slope of that yellow line? It's called the secant line. Well, we use the slope formula. I'm going to think what to call it. I'll call it m for slope. Well, let's draw our right triangle. the slope of that line is the change in y over the change in x. That is, it is this distance. Well, what is this point? Well, that point is f of x plus delta x. That height is f of x plus delta x. And what is the height over here? Well, let's see. Ooh, that's f of x. So the change in y is f of x plus delta x minus f of x divided by the change in x. Well, this change in x is this change in x. And we can compute it two ways. For example, if you want to know how long this is, you can do 8 minus 5 and get 3. Well, if you have x plus delta x and you take away x, you have delta x. Or you can say it was given. It was even given here. This is delta x. They call this m of the secant. Now, I kind of hinted that this line, the slope of this line, is not very close to the tangent line. So you know what we're going to do? We're going to make delta x a little bit smaller. I'm going to use the same x, but instead of putting x plus delta x here, I'm going to put it here. That is, this distance is delta x. Now, since I drew on the graph a lot, I'm going to erase it and try my very best to put back the same exact graph. Okay. So, this point, since that's x, and the name of the function is f of x, that's going to be f of x. Okay, and let's get rid of that line. So that's f of x. And because this here is x plus delta x, when I come up and I go across, that's going to be f of the x value, x plus delta x. What a strange name. Okay, so now we have these 2 points. We have this point, and we have that point. And you know what? I want to draw this curve a little bit steeper. We have this point and that point. Okay? And we want to calculate the slope of the line that connects these 2 points. We want to know the slope of that line. You know what? It's a little bit closer to the slope of this line. And what is the slope of this line? Well, let's complete the right triangle. It's the change in y over the change in x. But like before, the change in y is this distance. Change in y is that purple distance, which is exactly what I have up here, over the change in x. Well, if you have x plus delta x, and you take away x, well, you have delta x. And that's the change in x. Okay, now we're going to do this all over again, except we're going to make delta x even smaller. Okay, instead of this purple piece down, or this now yellow piece down here being delta x, I'm going to make delta x even smaller. Here's x, but instead of delta x being right there, x plus delta x, I'm going to make delta x really small. That's x plus delta x. That is, this distance is delta x. Okay. Now, you come straight up, straight across, that's going to be f of x. And if you come from right here, and you go straight up and straight across, that's going to be f of x plus delta x. And let's just get rid of these dotted lines. Okay. Now, f of x is right here, and f of x plus delta x is right here. And to the best of my ability, that's the exact tangent line. So it has a slope. It is a line. Now, this line, maybe I should have tilted it down a little bit. Yeah, let me do that. Otherwise, you miss my point. So we have this point. We have this point. Now, let me put it more on the curve. On the curve. This point, this point. Now, when I draw the secant line, you know what? It's starting to look really close to the tangent line, which I'm about to erase. And the slope of this line, the slope of that tangent line is the change in y over the change in x. And the change in y is this piece. It's f of that minus f of that. It's exactly what I have on the top. And let me just erase this. And this distance right here is just this minus that, which is delta x. Okay. Notice that the slope of the secant line is approximately what we call the slope of the tangent line at that point. Now, we're going to pick delta x to be extremely small. And to the best of my ability, please work with me. I'm going to draw the same exact curve. Let me draw the same exact curve. And it is still being called f of x. And here is x. And I want the slope of the tangent line right there. Well, if I pick delta x to be insanely small, that will be x plus delta x. Now, really hard for me to draw delta x, although I'll try, because the marker has some thickness to it. But that little piece in there is delta x. And f for delta x is going to be right there. So the lower one is going to be f of x, and that upper point is going to be f of x plus delta x. And if I draw, now this gets hard, but if I draw the line that connects the two, I will get my right triangle. That's the change in y, and that little piece is the change in x. And the change in y is the same as that distance, which is f of that minus f of that, which gives me my top formula. And this little horizontal distance in the bottom is the same as, hard to even draw it, but it's the same as this little piece here, this little piece there, and it's delta x. It's right minus left. Whenever you want to know the distance from 7 to 10, you do right minus left. Even if this was negative 7, it'll be 10 minus negative 7. We have negative 10 and negative 17. It'll be this number minus that number. Negative 10 minus negative 17, well, this means add 17, is 7. distance is always positive. So so now the slope of the secant line, the slope of the secant line, and the slope of the tangent line right at x is starting to look really, really close. Just like any line, I can make it longer. They're starting to look like the same line. And what happens is the following. When you so right now we have that f prime of x is approximately f of x plus delta x minus f of x over delta x. And this here is the slope of the secant line. The slope of the secant line, when delta x gets smaller and smaller and smaller and smaller, it gets close to f prime of x. So you know what? Why don't we take the limit as delta x gets smaller and smaller and smaller, that is, it approaches 0, of what's in here, which is called the difference quotient. Don't have to know the name. And then we say in the limit, we do get f prime of x. Okay, that is a good motivation, I hope, of why the derivative rule is what it is. And anytime you forget it, just remember that it's just a limiting process. Approximate, I don't care what curve you have, say that curve. Approximate the slope of the tangent line at an arbitrary x, the slope of this line, with the slope of the secant line. And then let delta, so this is delta x, let delta x get smaller, smaller, and smaller. Instead of using this point, let's use that point. Now, this secant line, so that's the real slope. This secant line is a little bit closer to the actual slope than this one. And if we come closer here, that secant line is the closest of all of them. This here is the real one. Okay, as delta x goes to 0, as x plus delta x approaches x, which means delta x goes to 0. As x plus delta x approaches x, f of x plus delta x minus f of x over delta x, this approaches the derivative. Now, this statement is the same as delta x going to 0. So as delta x goes to 0, f of x plus delta x, the slope of the secant line, approaches the derivative. The derivative is defined to be the exact slope. So, what this here means is the limit as delta x approaches 0, I'm saying as delta x approaches 0, this mess, f of x plus delta x minus f of x all over delta x, this is f prime of x. Okay, this is exactly the formula for the derivative, and hopefully now you see what it is. And anytime you may forget it, just do what I did. You think I walked around knowing this procedure? It's just extremely clear to me. Okay, this finishes this